Hi everyone. Today we're looking at adding and subtracting monomials. Let's take a look. First of all, we have to identify what is a monomial. You will see that right here we have the number 10. 10 is considered a monomial. It has an exponent of 0 because if we actually put a variable here and put a 0, that would make this 1 times 10, which would be 10. So we consider the degree 0 when you have a basic number, or what is also known as a constant. All right, let's take a look at this one. 3x, there's an invisible 1 here, so the degree is 1. 1/2 ab squared. There's an invisible 1 right here, so a to the first, b to the second. 1 plus 2 equals 3, so it's a degree 3. M to the fifth, there's your degree right there. It's 5. Let's discuss what's not a monomial. Okay, first of all, if you see a sum like 5 plus x, that is not a monomial. 2 over n, a monomial cannot have a variable in the denominator. So you cannot have a variable in the denominator and call it a monomial. Also, 4 to the a, that is not a monomial because you cannot have a variable exponent. Also, x to the negative 1, this is a negative 1. You cannot have that and call it a monomial. The variable must have a whole numbered exponent. Remember, whole numbers are the numbers that you grew up when you were little and you learned, like 1, 2, 3, 4, etc. Okay, those are whole numbers. So those are the rules. Let's take a look. So this one has a degree of 1 because technically if we have the x sitting there, it's to the first power. So that's degree of 1. This one is degree of 3, and this one has a degree of 0 because it's a number. We also need to know that the number in front of a variable is called a leading coefficient. All right, let's take a look at a question that we might have to answer. Write 15x minus x to the third plus 3 so that the exponents decrease from left to right. Identify the degree and leading coefficient. So what we do is we take a look here, and this one has the highest exponent, so we write it first. So we write negative x to the third power. This one also has an exponent of 1. So we write plus 15x. We don't bother putting the 1. And then the constant will always be last because its degree is 0. So plus 3. So once again, this is a degree of 3, a degree of 1, and a degree of 0. What's the leading coefficient? The leading coefficient is negative 1 because if you look right here, technically this is negative 1x. So our leading coefficient is negative 1. All right, let's take a look at the next question here. They ask you to please go ahead on your own and write this one as a decreasing exponent and identify the degree and leading coefficient. Pause your video and try. Welcome back. Let's take a look and see how you did. You would write the problem like this, with the exponent of 2, exponent of 1, and the constant. The degree is 2, because the highest degree in this entire equation is 2. So, the leading coefficient then is negative 2, because look in front, and it's in the lead, so it's negative 2. All right, let's try the next question. Now this is just a little table. It says tell whether it's a polynomial. If it's a polynomial, find its degree and classify it by its number. So number 9, it is a constant. It is considered a polynomial. It has a 0 degree monomial. This equation here has x to the second, x to the first, minus 5. So yes, it's a polynomial. It follows all the rules of a monomial. And it has a second degree, and it's called a trinomial because there are three terms here. So it's a second degree because the highest exponent is 2, and it's a second degree trinomial because there are 3 terms. Now this next one, it has an exponent that is a variable. So no, it's not a polynomial. This one here has an exponent that's negative, so no, it's not going to be a polynomial. Let's take a look at this. We have 7b, everything looks positive here, so this is going to be a polynomial, and it is the 5th degree binomial. How do you get 5th degree binomial? Now let's take a look. The highest degree of the b's is a 4. Well, that's interesting. I'll have to get back to you on that one and why it's a fifth degree binomial. Let's continue on. Oops, went too far. Let's try this one. Tell whether that this is a polynomial. If it is polynomial, find its degree and classify it by its number of terms. Otherwise, tell why it's not a polynomial. Pause your video and give it a try. Welcome back. Here we go. It is a polynomial. It follows the rule. And it is a third degree because there's a 3 out in the front at the top. And it's considered a trinomial because there are 3 terms. All right. Let's go ahead and we're going to actually find the sum. Sum means add, right? So these are actually pretty simple. We're going to go ahead and take the first question here, and we're going to line it up vertically. This is one method you could use. This is right here. This part is lined up right here. Oops. Let me erase that. It's the top. And then we have these terms. This trinomial is written down here. And what they tried to do is they lined up according to the degree. There's no constant in the first one, so you get -1. Add x, and there's no other x's along here, so we just have x. Then we have -5x squared and a 2x squared, so those are lined up. So you get -3x squared. And then they took the 2x to the third and 2x to the second, I'm sorry, plus x to the third. The ones that have the degree of 3, we put those in a line, and notice that that becomes 3x to the third. Now, what I personally prefer is the horizontal alignment. This is when you simply take the numbers and add this way. We look for 2 terms that are alike. So in the first grouping, we have 3x squared. The second grouping, we have x squared. So we put those together, and we get 4x squared. Then we have plus x. So we look in this expression, and we look for one that has an x. So it's 4x. So 1x plus 4x is 5x. And then we take a look at the constants. -6 plus 10 is a +4. So there's your answer. That's the sum of the polynomial. All right, here's one for you to try out. I prefer the horizontal. You can do it whichever way you'd like. Pause the video and try to add these polynomials. Welcome back. Let's see how you did. You should have been able to get 8x to the third plus 4x squared plus 2x minus 6. It's basically just combining like terms. All right, we'll have another video, and I will talk to you guys in a little bit. Bye.